brief that we covered in the first session. So first session is just totally about the basic retrieval system. So the basic RAG implementation. The first question is, why do we need the RAG? We have the multiple various types of chatbots that we can build. So there's a specific type of a chatbot RAG. Why would we need this type of a RAG, the RAG applications? And what are the applications the that we already used in nowadays? Like, anyone have any use case? Do anyone have some idea about the any application, any platform that we use generally, and that is the RAG based application? Any popular application? Anyone have any idea? What about the chat GPT? Is the chat GPT is a RAG application or not? Just a simple question.
Yes, ChatGPT is RAG application.
Okay. So chat GPT is a RAG application. In what manner you can say it's a RAG?
Because it accepts the all kind of documents like a PDF, and it processes internally.
Okay, right, yeah. So yeah, the basic retrieval system, what the RAG is based, basically the basic concept of the RAG is just the retrieval system and with the augmentation and the generation. So first we discuss about what is the RAG stands for. Why we would call this as a RAG? The first question is why we call RAG is RAG. What is this specific name? It stands for the RAG, the retrieval augmented generation. Okay. So first we need to just discuss this thing, okay, this title of this RAG. So why would we call the RAG is a retrieval augmented generation applications? So, and when we use this, already we have covered everything on the first session, and I want to just clarify few things in details. Okay. So specifically, if we go for the if we build any architecture of any chatbot, so what we have, we need one component as a user. Okay. So something like a user, you can say user, and one component is LLM. So any simple chatbot is just asking question to the LLM, and LLM will respond accordingly to the questions the user queries. Okay. So the simple chatbot, the user asks questions to the LLM, and LLM responds according to the question. Okay. This way, the queries of the user goes to LLM, and the response on based on the queries goes from LLM to the user. This is the user component, and this is the LLM. Okay. This is the basic behavior of a chatbot. But why would we need the RAG? Because we don't rely on the LLM information only. Okay. In the real world scenarios, we have a lots of scenarios where we don't rely on the LLM information only. Okay. Because we know that LLM have a more information. LLM is capable of generating something new content. But LLM also have some drawbacks, some sort of information lack, where we need some external data, okay, some external source of information to attach with the LLM. So LLM can generate response based on the external information also. So for that purpose, we introduce one more component in the basic chatbot is the database. We would say the query database. Okay. So we can see the vector DB, some sort of a DB here. Okay. Now the retrieval augmentation problem just changed. The response will not change. The response system will be same. The LLM respond directly to the user, but the input system is getting changed with the RAG. How? In simple chatbots, we generally ask to the LLM like this, but in the RAG system, the user directly asks the question to the DB. Okay, basically, user asks some queries, and user wants some response based on the queries, and the query can basically can require the information which is not present in the LLM information, the LLM trained on information that is LLM already trained on, because LLM is just having the information on the database where it's already trained. That's why we call the pre-trained models. LLMs are the pre-trained models. GPT stands for the pre-trained transformer architecture. So pre-trained model has the ability to generate the response, but based on the trained concepts, the trained information, the trained data set. If we want some information that is not in the LLM trained data set, so we need to augment this information with the LLM information. That's why we say there's a retrieval and the augmentation. So what is this happen? How this happen? The user just asks query. The query goes to the database, and the database retrieves some documents, that additional information is a retrieval process. That retrieved document, retrieved context, we can say the retrieved context goes to the LLM with the user query. Query also goes here in the LLM. So with the context, the user query also augmented. You can say basically the query is augmented with the context, and the response will generate based on these two information, the query plus context retrieved from the database, the additional source of information. Then LLM can just generate the response based on the query and the context, and that response goes to the user. So we can say this is the retrieval process first. So why we call this RAG? Yes, I'm coming on you. Just hold a second. Okay. So why we call this as a RAG? Because this is a retrieval process here. We can see the retrieval process, the retrieval of the information from the vector DB or any source of information that we want, and then this retrieval goes to the augmentation. Retrieval goes to the augmentation, and then it goes to the generation of the response. This is a basic architecture of the why we should call the RAG system the retrieval augmented generation applications, because there's three components, three basic strategies that is implemented in the RAG systems: the retrieval process, and the augmentation process, and the generation process. And the tools and the technologies that required to do this, we already covered in the first session. Okay. Yes. Anyone have question? Any question is?
It's good.
Vijay. Yes.
Clear.
Yes, Vijay.
It's clear, sir.
Okay. Okay. Thank you. Okay. So this is the basic retrieval process. Okay. How the RAG applications work. So this is a basic retrieval augmentation generation process, and we already implement this in most of the chatbot, the running chatbots in the nowadays, because every industry, if we want to build the industrial chatbots, so every industry has their own data. Okay, and they don't want to rely on the LLM information. Basically, there's a two way. Just one way to just to secure their data, and the another way to just giving more information to the LLM besides just relying on the LLM information only. Okay, so if we want to just build some customer system chatbot, or basically just interactive chatbot, that we can rely on the LLM only, because LLM have those information, LLM have the ability to just generate the response based on the queries. But if we want to back up some the response of the LLM backed up with some context, some specific information, some data based on some specific system, so that's we need the RAG system. Like for example, I want to build the chatbot for a hotel industry, for example. So I have to just build a one industrial chatbot for hotel industry. So if we go to if we want to build this chatbot, so we can't rely on the LLM because LLM can't generate a specific result, specific informations. So for example, if we want to build booking.com, okay, the chatbot for the booking.com is a platform for booking the resorts and the hotels, the rooms in the hotels. So if we want to build this chatbot, so we need some external information with the LLM response generation to back the response of the LLM with some sort of information of the each resort. For example, one user came to the booking.com website and he wrote on the chatbot that he want to just know about the cancellation policies of a specific resort and what are the other information, this room is available or not. So is that information, can we imagine that information LM should have that type of information in their own data set, the training data set? It's not possible because there's something related to the specific organization. So if we want to back the response of the LLM with the information related to the only the organization information, then we need that type of a chatbot. This is the application of. So yes, nowadays every industry is now relying on the RAG information because every industry has some their information and they want to back their responses with those informations. Okay. So it's some sort of a giving some more additional information to the LLM, and then LLM can able to generate the response based on the user queries and also on the based on the given information. So this is the basic RAG implementation and why we would use these applications in most of the we can say the industrial works. So this is the basic retrieval process, and retrieval we can also build this as a graphical way. If I want to build one graph here, so first will be the query of the user, then query goes to vector DB, and then retrieve the context, matching context we can say, because in the vector DB we have a we can build the vector DB of 100,000 of pages of a PDF or some other informations like a from web source, from the Excel information, any other. We also can build the vector DB on the image data set by using the OCR technologies also. So we have OCR technologies, so we can read the image information by with the help of OCR technologies from any sort of a image or PDF content where the PDF have the images. Then we can generate the vector DB. Okay, the vector DB is just the vector representation of the we can say the textual information or the embeddings. Okay, and those vector DB, why would not use the simple DB? Why would just use the vector DB here? Because we need to just compare the query with the context that we already stored in the database. That's why we need the vector DB, because we want to just compare the query, because we need the matching results. We need the retrieval process. We need the highest scoring retrieval process. So that we already covered in the first session. Okay, how we provide, how we just match the score. Okay, how the score is given, or how the document is related to the query. Okay. So that's why we need the vector DB here. The vector DB just, we can't use the simple DB here because we want to just relate, we want to just compare the query with the stored information, because we want to just retrieve only the matching context. Okay. We can't load the all of the context to the LLM because LLM token size will expire. Okay. So we need to just focus on the specific type of retrieved context. This is just like a bound with the some sort of a 4 matching documents or 4 matching chunks. Okay, like this 5 matching chunks. So that is the retrieved context, and after that we will move towards the LLM for the response generation and the response. Okay. This is a basic graphical representation of any RAG application. So that's, we already covered in details all the tools and technologies that we need to build this type of a chatbot, the RAG applications. Now we will move towards the RAG applications with the agentic modules, agentic tools. Okay. So any one of you can tell me about the agentic. What is agentic AI? You heard about this agentic AI? Anyone knows anything related to the agentic AI? What is agentic AI? It's very popular nowadays.
Um, that's doesn't wait for the human prompts. Means it much advanced.
Yes, we can say, but why? What is agentic AI? Why we call this agentic AI? Anyone else? Just anyone have any idea about the agentic AI?
It will do some kind of a task using some AI.
Yes, yes. You are
Uh,
just
it
50-60%
operates with
correct.
agency.
Okay, okay, okay. Thanks for the response. And now I'm going to this topic agentic AI. Okay.
Like what we have listened that in a future that many people just want agentic managers, so just they can see what they are doing agents like much
Yes,
efficient.
you specified a good example here, but okay. So I'm just going to little bit on the deep of the agentic. So what is the agentic AI, and why would need the agentic tools in the organizations rather than the just a old, you can say, the conventional technique of the AI, like a Gen AI applications. We now we are just combining the Gen AI with the agentic AI to get some advanced features, some advanced response generations. Okay, so specifically for the RAG application design building, the agentic AI just the method of combining multiple agents at the same time to perform a specific task. Okay, the agentic AI is a we can say it's just uh, the, the term used to for the agents that where the multiple agents collectively work for a specific task. Example, we build agent 1, agent 2, agent 3. Okay, and that's all. Most we can have the many of the agents here, and they all are working simultaneously at the same time, we can say, or collectively, we can say the collectively to perform a specific task, user specific task. So multiple agents are working collectively, they're working simultaneously to perform a specific task. Okay, so that agent can be a different. We can say that an agent can perform a specific the different task. For example, agent 1 can be for the retrieval of the database context, agent 2 for the web search, agent 3 for the another purpose, just for the response generation, just formulating the response, and also we can combine this with the email formulation. Okay, so this type of we need to build a separate agents for specific tasks. Okay, so each agent have some specific responsibility to do, and collectively all the agents will work at the same time to perform a specific task. How? So if for example, user asks any application, any agentic AI application, so that's I want to just for example, I want to just retrieve that information about the, for example, I'm just building a hotel RAG application. So so here the user is asking to just retrieve that information and booking, and also if we found the minimum cost, like a cost of any sort of a, for example, user asks chatbot or any agentic application to just book a room in XYZ, any XYZ resort, one bedroom, and for a specific type of amenities, and with the range of a 300 to 500 per night cost. Okay. So what agent do? Agent just go for the information retrieval. Agent 1 will active, just retrieve the information Where is this resort present? What is the cost of each room? If there are any matching room, 300 to 500K per night cost room, one bedroom. Yes, this is the resort. This AXYZ is present with this specification, with this what user is specified. And then after this retrieval process, the agentic module go for the agent 2. Agent 2 will go for the booking process and just generally book a room on the resort, this one. And then agent 3 will active. Agent 3 give the response on the WhatsApp to the user. Okay. So all the process will work at the same time. Only the one application will work. And for the user perspective, user just write a prompt, just a query, just do this work for me, and all the process simultaneously work at the same time from the single application. That's the mean of the agentic AI. In simple words, I want to just explain in a very simple language without using any financial terminologies that we already use and CP and other tools. That's it. So I don't want to use that fancy terminologies here. I want to explain just a layman terminologies so you can easily understand what is the agentic AI. Okay. So the agent can perform a specific task, and collectively those agents will work for the specific task, and they just do collectively work and just perform a specific user task. The goal is built by the user. Okay. You need to perform this task. Okay. And for performing that specific goal, to achieving that goal, the agentic module will just call the agents based on the user specified task. Okay, we can say it like this. So who is the planner here? When to use which agent? The question is, yes, we have the agent 1, we have agent 2, we have agent 3. We can build it by using any Genie application. So we can say the agent 1 is a RAG who is retrieving the document. Agent 2 is just booking the room, just placing the booking on the resort, basically on the website. And the agent 3 just giving the information on the WhatsApp, just providing the response on the sending a message. Your room is booked on this location and this on this date, like this, and they're just giving the response on the WhatsApp. Okay, so it's a whole process. But which agent will work and when to work? So who is the planner here? Someone need to take a responsibility to plan the concept. So maybe this time the agent 1, agent 2, agent 3 is just a process to just work from the sequentially. The agent 1, then agent 2, agent 3, but not the it don't like we need to just go for the every case like this. Not on the every case, we need to just go for the sequential manner on the agent, like agent 1 to agent 2, agent 2 to agent 3. So we need to just build one planner here who can plan the agent calls, which agent will work and what time will it work. Okay. For example, like I use this the specific terminology, this technique, and if I want to say just for specific this type of chatbot, and user asks something related to like he want this information, for example, the retriever information, the specific resort information only. Okay, he don't want to book the room. He don't want to just get the response on the WhatsApp. He just need to clarify is this type of a room is available and is this dates are available on the particular resort. Then we only need to use only the agent 1. We don't need to just go for the A2, the agent 2 and the agent 3, because the every information is just the user is asking for the retrieval information only. This type of a room is available or not for particular day. So this type of information we need to just call only the agent 1, because agent 1 can specifically get for this type of a RAG information task, has a RAG task. So it can retrieve that information from the database. And after that, user don't need to go for the user doesn't specify that he need to book a room. So after that, we don't need to go. Basically, the agentic model don't need to go for the agent 2, agent 3. It directly respond to the user here. Okay. Only us using only the agent 1. So someone need to take responsibility to plan here. which agent to use and when to use and how to use. Okay. This planner is the LLM here. LLM is the planner in the agentic modules. It plans the whole task, which, for example, just the user just gave any task to the agentic module, then it directly goes to the LLM. The user query goes to the LLM, and then LLM plan the task. Okay, first, we need to use the agent one for this type of a task, for just like a just retrieve the information about the cancellation policy of the specific resort. Okay. So user just ask the question, and then LLM plan accordingly when to use the agent, how to use the agent, and where to use the agent. Okay. So these three tasks specifically LLM plan here: when to use, where to use, and how to use agent. This is a complete basic theory of the agentic AI, how the agentic AI modules work. So basically, it's a collection of
So
the
it is
multiple
done
agents.
by on, right?
It is done by,
It's on.
sorry,
Means ये खुद ब खुद अपने आप ही करेगा ना?
okay, yes, exactly. So it just user need to just say the query, just tell the query, just specify the task. We need to perform this task and just give me this response, anything like this. User just need to give the query to the agent, and the agent will work accordingly by using this LLM planner. LLM plan the task accordingly, and after that, it will do all the tasks at the same time. Okay. But just only for the same single instruction of the user. The whole process of the agentic AI. So how we can use this agentic AI in the rack system? This is a basic agentic module where we have a multiple agents and they collectively work for each specific user
एक
specific task.
उसामा भाई एक बार और ये A1 A2 A3 वाला दोबारा से एक बार समझा एक्सप्लेन कर
Okay.
देना दोबारा
So
एग्जांपल.
yeah. So we have a three agents, for example, A1, A2, and A3. A1 agent is just we can say the responsibility of the A1 the agent one is to retrieve the information from the database. Okay, because we are building some a chatbot. This is the agentic application for the booking.com, for example, where we need to just book where the work of the organization is to book room or the hotel on the behalf of a user. Okay, user just go use that platform to book the resorts, to book the room on the resort, for example, just like a OYO and the booking.com. Okay, so for that purpose, we build one application, agentic application, where we use the multiple agents. So one agent is just for retrieving the information what this resort have, what type of a resort is already OYO is supporting. Not all the hotels are OYO is supporting or booking.com is supporting. Okay, so there's a specific resorts for each location. For example, on the Delhi, so not all the resorts are just listed on the OYO on the booking.com. Okay, only the specific resort that has already tied have the tie up with the booking.com, they already have the listing on the booking.com. Okay, on the OYO, for example. Okay, so this for is this type of information, we need one agent to just retrieve the information what we have. Okay, just retrieval process. And we also build one agent 2 just for the booking the room on the website. Okay, and we also have one more agent, agent 3, to just give the response to the user on the WhatsApp or any platform, any social media platform. Okay, for example, we are using here the WhatsApp. Okay. There are 3 agents. One is for the retrieval of the information, one is for the booking the room, and the third one is for the just giving the response on the WhatsApp that your room is booked on that location on these dates, and on the just like the complete information of the booking on the WhatsApp. Okay, there are 3 agents. So if user asks all the info, just find out if this type of resort, for example, the cost of the per night cost is 3K to 5K in the range of this, and this is a specific 2-bedroom set, and these are the amenities should be present in this room. So this is a type of a query user asks to the agent to just perform. And another task is to just, if you have this information, if you have this type of a room available on particular date, for example, July 15 to 20, then book this room for 5 days and book this room and give just he told to just book this room. Okay, what agent will do here? Agent just go for the agent one because LLM will plan. So according to the user specific task, LLM plan when to use which tool is to use. Okay. So first in the user query is to just check that these details if this type of a resort is present in database or not. Do you have this type of a room set or not? So for checking this information, we need the retrieval of the data. So RAG application, basically not the RAG, you can say the RAG system. Okay. For example, agent one. So this retrieving the information from the database and checking. Here the LLM is checking that this type of information, this room is available or not. For example, okay. So agent one just find out that yes, this room is available. Then LLM goes to the agent two, agent one, then agent two, and just instruct agent two. Just we have this information like a XYZ resort, this room Q1. Okay, books this resort for 15 July to 20 July. And agent 2 will do this all work, book this room. Okay, because agent 2 has this specific task, this has the responsibility to book the room for specific information. Okay, on the behalf of a user. So it will do this. It will directly go and book this room on this date to this date, agent 2. And then after that, LLM, after that, it's respond to the LLM that I have booked this room. Okay, I have done this. I completed my task. Then LLM use another task. Go to the user query and just check if any other task is remaining. The user told to just give me the response on the WhatsApp. Then it will go for the agent 3. Otherwise, it will not go to the agent 3 if user not want the information on the WhatsApp. Okay. So this type of a technique. So we need the multiple agents to work collectively to just perform a specific task. Correct? I hope you understand the agentic here. Okay. Yeah. Thank you. So this is I just explained it in the broader terminologies, but our focus is to just build the RAG application with the agentic module. Okay. So how we can implement the RAG with the agentic module, like agentic application. Okay. So that's our focus, to just build the RAG application with the agentic module, where the multiple agents will work collectively to perform a specific task. So I just gave the example where multiple agents have a very broad concept. Okay. One is for the table, one for the just booking, one for the response generation on the WhatsApp. Okay, but now I want to just build a RAG system that can behave like an agentic module. You want to just create. By the way, these agents are called as a tool. In the AI terminologies, in the fancy terminologies, we can say in the industrial terminologies, these agents are the tools. Okay. So the agent 1, agent 2, agent 3 these are the tools. These are the different tools that LLM will use these tools to perform a user specific task. Okay. So in the on the RAG building, if we want to use a multiple tools for a specific retrieval augmented generation process, so how can we use it? How can we leverage agentic module here? Any idea? What is the use case? How we use this agentic, the multiple tools working simultaneously to just retrieve the information? Is any idea? Anyone have any idea? How can we integrate the agentic? What is the use case of agentic in the RAG system? Okay. Okay. So we already know about the agentic system, and also we know about the RAG system. RAG is just a retrieval process, just retrieving the information from the database. Okay, and just giving that information to the LLM, and the LLM just generate a response and to the user. Okay, this is the basic RAG application designing building architecture. So if we want to integrate, we want to just leverage the agentic, we can say the agentic application, okay, on the RAG system. So how can we leverage it in the RAG building? What is the use of the agentic here? Because we already have this process of retrieval augmented generation. We already have this process. So why do we need another tool for it? Okay. For that, I'm explaining what is the use of the agentic in RAG. So first, I want to just go with the graphical representation. So we have the query, user query at first. Yes, anyone have a question?
No, I want to say something like some, if it is good to tell or not, for automating purpose, as agentic AI is independent, so they can perform their task by own. That's why we are using agentic AI in a rack, so that if anyone query, like he wants booking, as your examples, wants to book something in a hotel or something, so automatically system run on a behalf of that query. That's why agentic AI need. Is it
But it will
little bit?
do if we don't use the agentic, then also it will do the same. Okay. My question is just like, if we don't want to use the RAG, then also it will do the same. It will go for the response generation. If we ask something related to the information for a specific, for example, booking related information, it will go and retrieve that information, check this information is available or not.
So I think agentic AI doesn't do by its own because it's a specialized in a rack system, and there is a database which is for the database purposes, the PDF purposes, RAG is a specialized. So that's why agentic AI use the RAG, right?
Yeah, let me explain. Okay, thanks for participating. So what is the use case of an agentic module in the RAG? Okay, so how can we leverage this agentic module in the RAG building? So first we have the query, the user query, and there's a multiple technique, multiple approaches, multiple use cases that where we can use the agentic module in the RAG system. There's not only a one way. There's a multiple approaches. There's a multiple use cases where we need the agentic module. We can't just go without the agentic. There's a very much, we can say, the various applications, various use cases. So for example, I'm explaining one. So we have the query, user query, and we have a multiple database. There's a one approach that we have a multiple database. One database is for the booking information, for example, resort information. And another vector database just for the employee information of the company. This is the resort information, anything related to the resort. For example, I'm building for the booking.com. So this is the resort information that's already listed over the booking.com. And this is the employee information that are working on the booking.com. Okay. Then if user asks a question, so it can be any one of these two databases. It can be from the resort information, it can be from the employee information. So what agentic here do? Agentic just plan the task, just decide which database to use. Decide which database to use. Okay. The agentic means basically the LLM have the decision power, the decision making power. Okay. That's why we call this it the planner. Planner means it have the decision making power. So here the LLM will decide which database to use to just retrieve the information. Retrieving the information from here and just combining the response, the augmentation and the response generation. The generation, you can't say the R, this is the generation, G. Okay. This is one use case. Another use case. We have a user query. User asks something and it go for the retrieval process, vector DB. Okay. And then generate the context Now the question is response of the LLM. So the question is, what if the data is not present in the vector DB? Okay? Users ask something like uh, anything new, anything about the information that is not present in the vector DB and not on the LLM information. Like if we ask something like write a code, write something, then LLM can respond. Okay. What if the vector DB fails? The question is in the vector in the RAG. What if the vector DB fails? So if we go with the simple RAG application, how the LLM will respond? My question. If the vector DB fail, how the LLM will respond? Any one of you can respond. Just reply it. We already covered everything on the basic building of the RAG. So if the vector DB fail, if we don't have the matching context in the vector DB, then what? How the LLM will respond? From where? Anyone? Anyone have any idea?
It may respond from the which are having the lowest number, right? The vector distance.
Yeah, okay, right. But yes, you are right here. Just like if for example, I uploaded the document related to the uh, resort information. Okay. And if user asks something outside of the resort information, okay, it asks them related to the news information, for example. Okay. Yeah, something like who win the last year FIFA World Cup. Because it's a user, it can ask anything. It can play with the chatbot. It can test your application. Okay, because it's the end user. It can find the glitch from your system. So it can ask anything. It don't ask only the information related to the only what is already stored in the vector DB. It can ask anything. Okay. For example, we found one of the Amazon site. Okay, once I just tried last year. I don't know what happened now. So on the Amazon e-commerce website, on the chatbot, if so that time I asked to just write a program for Python program for just adding two integers like this. So it responded to me, but generally it will not respond. It the task of this chatbot, the e-commerce chatbot, is not to just write the code, right? Write the code of the Python, because it's the e-commerce website chatbot. So that chatbot should respond only from the data that is only in the available in the PDF in the website, because user just generally ask. User don't go for the just writing the code on the e-commerce website chatbot, right? Because we have already lots of a chatbot to just write a code. So we don't go for the writing the code from the for the e-commerce, because they build that e-commerce chatbot, the website chatbot, just for the information related to their products, to just give the response on the based on their products information. But that time I tested to that chatbot also generating the response on the program. You can also test it. I don't know what happened now. So you can also test it now. Maybe it will, they restrict that chatbot. But that time I just last year I tried. So this is the fallback here. If the vector DB fails, if we user asks anything outside of the vector DB, then what happens? So in general chatbot, okay, in the basic RAG applications, the chatbot respond on the base of the LLM information. Okay. If the vector DB fails, if the context is not present in the vector DB, if the user asks outside of the vector DB information that is already uploaded into the system, then then the LLM use their own information to generate the response. If the data is not present in the vector DB, if the context is not present, then LLM use its own information, its own learning to generate the response. Okay, that's why generate the programming question, the response of the program, because LLM doesn't get that information from the vector DB and generates the response by its own information. Okay, so just the simple the fallback in the basic RAG applications. If the vector DB fails, then LLM use their own information to just generate the response. Right? Okay. Understood? It's clear now? क्या होता है? For example, if you want to build a simple RAG application, अगर आपका vector DB fails, if your vector DB fails, then what will happen? It's common. Okay. So it's not just like a simple, can't say that it's a glitch. It's a fallback logic. Okay. If vector DB fails, then we will move towards the LLM response, LLM's information. Okay. That is replaced in the agentic, because we don't want to go for the just LLM information every time. Okay. Maybe the LLM has that information, the LLM can respond it. But if the LLM also don't have that information, like for example, I asked to any chatbot just who is the winner of the last year FIFA World Cup or last FIFA World Cup. So that information will not be in the vector DB. It's also not present on the LLM response. Then what will happen? Okay, I just place an example of this. Okay, so don't relate directly to the vector DB. This is it's just like a hypothetical example that a user asks for the who is the winner of the last FIFA World Cup. Okay, so that time what Agentic will do, we need to build one more agent. This is the agent one here. Agent one, who is just having the vector DB. And also we have one more agent here we can build for web search. This is an agent two. So if the context is not present, then go for the web search. Okay. If vector DB fails, then go for the web search and just find the response from the web, basically the Google, you can say, and it web search. Okay. If that information present on the web search, respond to the user. Okay. So this is the process, okay, of the RAG application. So we need the agentic module here. We just replacing the fallback logic from the just directly going to the LLM response. We just build one more agent here, agent 2, just for the web search. If that information is not present in the vector DB, then automatically the agent goes, the LLM goes to the agent 2. It first go for the agent 1, find the relevant document. If it's present, then go to the response generation. If it's not present, then if yes, and if no. If no vector context is available, then just go for the web search. If the web search, the data is available on the web search, then respond to the user according to that information. If it's not present on that, then go for the LLM response. This is one more use case of the RAG with the agentic module. And one more specific use case of the RAG is also a most commonly used application, the use case of the RAG. I already told you that there's a multiple applications, there's a multiple use cases to use the RAG in different scenarios. Okay. So one important scenario is the query and user asks for a database to just respond. And this is the vector DB and the context, LLM response. Okay. So here we don't want to just use any other type of agent like a vector DB, anything. Just on the same for the retrieval process, we need the multiple agent, but we need the agentic technique, the LLM planner, to just decide if the retrieved document is sufficient or not. Here we don't need to just basically create a one more agent. On a single agent, agent 1, we leverage the agentic module, just a one agent. Okay. But we can use the agentic technique here also on the basic RAG retrieval process. How? If user asks anything, just like that will not present, because for example, we uploaded multiple documents, for example, resort 1, resort 2, and resort 3. Okay. And user asks for any type of information that is present in all these 3 resorts. Okay. Anything just tell me about the result 1, this information, and this information from the result 2, and this information from the result 3. Okay. The user asks the very complex query having the multiple response, just that needs a multiple retrieval. Retrieval from the result 1, retrieval for the result 2, retrieval for the result 3. Okay. So in that case, user asks the query, it goes to the vector DB. LLM is a planner here. What it will do? Just for first go for the vector DB, it just retrieve the documents, the context, and then LLM okay, just check the context, the retrieved context has the sufficient knowledge or not. Okay, क्या check करेगा? The retrieved context has enough information to fulfill user request. Okay, understood? So if just LLM just check the context, if the context have all the information what user asks, so maybe is there any chance that result 1 data present in the context because the query matched with the vector DB, so most related document will retrieve, so it will retrieve a result 1, okay, based on the user query, and maybe there is a chance that result 2, result 3 data is missing. What LLM do? LLM will just rewrite the query. क्या करेगा? Rewrite the query. Rewrite the query again. Just formulate it for to retrieve this information, result 2, result 3, and again go to the vector DB. Okay. So I in the direction of this, so like okay. It's like a LLM in the loop. The vector DB, the context, and the LLM is in the loop. What LLM will do? Just decide the retrieve information is sufficient or not. If the retrieve information is sufficient, then go for the LLM response. Is it sufficient? Then go for the response. If it's not sufficient, then again go to the vector search. Again go to vector DB and just retrieve the relevant information. If it's not possible with the same query, then LLM will rewrite the query according to the user specific task. This is also the application of Agentic in the RAG applications, the retrieval augmented the generation applications. So we can leverage the Agentic module framework, Agentic module application in the RAG building. So I hope you all have the clear idea, the image of how the Agentic will work. Yes? Anyone have any doubt?
Just I have a doubt. How you are telling
Yes.
is having enough information or something like that? How it?
Yes. Yeah, it's a good question actually. So how LLM will decide that the information is enough or not? Okay.
Yes.
That's
correct.
why we so that's why we call the LLM is a decision maker here. So in that case, you need the two LLMs, just one for the response, the information response generation. Okay, this one, and one for the LLM as a decision maker. The decision maker has the specific instructions because we specified the instruction to the LLM. That's like a prompt, writing a prompt. Okay, so we specify by using the system prompt the LLM to just check the retrieve context and the query is it relevant or not. Okay, so the LLM have the guidance to just retrieve the context, check the retrieve context, and the query just match, just decide, because LLM have a very good just we can say the reasoning power. It can generate this response is this the information is relevant to generate the response or not. So LLM can generate the response also. The LLM has the capability to generate the response. So when the LLM generates the response, it generally generates the response based on the provided context. So if we use the LLM as a decider, not the response generator, so it can also do that task also. It decide whether all the information that is written in the task that is specified in the user task is present in the context or not. By seeing the context data, the chunk of the text, For example, we retrieve the four matching chunks. Okay? 4 matching chunks, the textual information that we retrieve from the PDF. Okay? So that 4 PDF content doesn't have the information about the result 3 data. The LLM just read, LLM just see all the information, the context. Okay. After seeing that information, LLM just respond, okay, there that information missing, result 3 information missing. Okay. So here we use the LLM as a decision maker, not a the response generator. That's why we need the LLM in every GenAI applications, because LLM have the more very powerful model. LLM is a very powerful. It can do multiple tasks. It just not only for the generating response only. It can do the reasoning. It have the reasoning power. It has the decision making power. It can decide this information is sufficient or not by seeing the query and the database and the context. Right? Vijay?
So you are meaning that similar like some kind of question similarity, whether the generated and the request are same.
No, it's not like the sensitivity. Just for example, you already use the maybe you use the chat GPT, right?
Mm-hmm.
Okay, so in chat GPT you can build up, you can easily say it just give any context and just ask this data is present in this context or not. Just you can easily do this. Just upload the document and then ask LLM, the chat GPT, just find out this information is present in this LLM this uploaded document or not. We can say, or we can do it or not in the chat GPT.
Yeah, we do.
We can do it. So what
Yes.
LLM will do here there? Just LLM just matching the query with the PDF information. Is this information is there's no consensibility. It's the LLM itself is capable of deciding, making a decision based on some information.
Oh, got it. Thanks.
Yeah. So here the LLM have this capability of the decision making. That's why we use the agentic here, because we know the LLM is very powerful entity. So before that, when we are just relying on the GenAI, we are just restricting the LLMs only for the GenAI power. But now we have the agentic module where we are just using the very we can use the big power of LLM, which is the decision making power. This is a beyond for the generation. Generation power is just a very little, we can say very less as compared to the decision making power of the LLM. That's why the Anthropic build, the Cloud build, that's so much powerful applications, the agentic applications, because of the LLM capability of the decision making. So
Okay.
in and query system, the retrieval process, we can also build the agentic RAG where we use the LLM as a decision maker. So what in this use case, what LLM will do? LLM just see the context and match the query. Is this context is sufficient to respond to the user or not? If it's sufficient, then the LLM just generate the response. Just move towards the generated the LLM that is doing the response generation process. And if that context is not we can say the sufficient for the generating response, then LLM go again for the vector retrieval. And if it's required, it's not the case every time. It just directly, it can also go directly for the vector DB response. So that's why we can say the LLM is just acting like a human. If you go inside the agentic, you will also just explore the capabilities of the LLM. LLM just like a human. It acts sometimes like as a human. So it will just see the query and it just decide whether to rewrite the query or not. It is required to rewrite the query or not. If it is required to rewrite the query, so that's also the power of the LLM. It decides that we need to rewrite the query for the again vector retrieval or not. If it's required, then it rewrite the query and rewrite the query according to the vector retrieval. The whole process here, the LLM will act just like a human. It's human intelligence. It decides whether to rewrite the query or not based on the retrieval process. If the query is straightforward, then it go for the direct vector retrieval. Again, just retrieve another information and the package of the context, matching context. If it's required that not able to just again and again, it's not like a one time or two time. Unless the LLM found the sufficient information LLM go for the in the loop again and again, checking the vector DB, unless it found the specific information. Can be multiple times. Okay.
Whether we are having any samples today to understand the. Now I understand, but if I see anything practical or some of the example.
Yes, I'm going on it right now. Just we already covered 1 hour in the explanation. Now we will move towards the practical information. Okay. So now we will build this agentic RAG with the, because we need this the theoretical parts because without this theoretical concept clearance, we can't easily understand the what is happening in the agentic while we are building the agentic model in the Python application. Okay, that's why we need this explanation.
Got it. Thanks.
Okay, let me. Functional screen again. This is my notebook. So I'm just using the Collab here, Google Cloud Platform, just for the easiness, because it's a cloud platform. Is everything is already installed with the highest package version, highest version. So that's why it's easy to build up for the just POCs, not for the real application building. So you need to just copy paste this in the local system if you want to use, if you want to just build the real application for the user. So just you need to copy paste this code in the your ID like VS Code, so you can build up. But code will not change, just for the implementation, for easiness, and for the just implementation purpose, because we are just doing this for the POC, for the demo only. That's why I'm using the Collab here. But that will not be any harm to us while we just you need to just go for the build the same application on the your ID like a VS Code or anything. Okay. So first we need to just install some the important libraries. So when we go for the any type of a project building, then the first step is to just set up an installation. Okay. Installation of the required packages is mandatory, because if we want to use any type of a package that is for the building any rack with it, we need to just install it in your notebook first. So I'm just installing all the packages. I'm installing the LangChain, LangChain OpenAI, LangChain Community, LangGraph, ChromaDB. So we already know that why we use it. The LangChain community is not why we require the LangChain. Okay. And the LangGraph specifically, I'm just using LangGraph here. So I will show you two methods of building any agentic modules. One with the LangGraph and one with the LangChain tool method. Okay. So you can easily compare apple to apple, both the technologies, okay, both the frameworks. LangGraph is also used for the creating a workflow, the agentic workflow. The ChromaDB here is for the just a vector DB. We can also use the files, and that's why we use the files GPU, PyPDF for the reading document from the PDF. Okay, that's it. All the packages are installed first, and then I have to just put my API key, the OpenAI API key, because I want to just use the OpenAI here for the embedding generation and the response generation of the LLM. That's why I'm using the OpenAI here. So I'm just keeping the OpenAI, just put that API key in my secrets of this Collab notebook. And from where I fetched this API key and store it in this variable, just for the implementation of the API key. So now the part is start for the RAG. So in the RAG system, we have we can say basically two modules. One is the static module of the vector DB generation, where we just upload the document, chunk that document, split into smaller chunks, and then create the embeddings, and I store it into vector DB. That's a one-time process. Just create a vector DB. And while in the second module, when the user asks query, you need to just go for the vector DB for the retrieval process, and then for the and to the LLM. This is another module. There are two modules. One is a static module. Just we need to just run it on the once, where the vector DB creation. The vector DB, how to create a vector DB? You need to upload the data. For that, I'm just uploading the document, just importing the Py PDF and the text splitter. You already know everything about it because we already saw it in the first session. Okay. So document loading and the chunking. Okay. I uploaded one document here, chatbot PDF like this. We can upload anything. Just put it here. This one. Any type of a loader. The document. Okay. So this simple way to just read the text from the PDF. Okay. Again, I print one that information from one of the page. Like we have a 3-page loaded. So the PDF have the 3 pages. Okay. So first page have this content is a mix of information of the about the Grok API and something in this PDF, and also some sort of a code information for the LLM building chatbot, okay, using Grok. And this the text splitter, recursive text splitter. I'm using the chunk size 1000 and chunk overlap 200. Yeah. If you've found anything if you got any doubt, you can ask immediately. This is text splitter. Okay. I split that document that we retrieve just retrieve from the PDF. Okay. The 12 chunks is created. Now embeddings, I'm using the OpenAI embedding module here for just creating the embeddings and storing it to the vector DB. Imported the LangChain OpenAI from the LangChain OpenAI, the OpenAI embeddings. This model is very fast and a small model to generate the embeddings, and also very good result. That's why I'm using this one. We can use, there's a lots of embedding models on the OpenAI also and other platform also, and we can also use the Hugging Face also for the open source models, because for the OpenAI we need to pay some sort of amount to the OpenAI because it's a charge. So OpenAI charges for using their models. Okay. So if you want to go for the free version, we need to use either the Hugging Face modules with the open source models for the embedding generation. Because it's a one-time process, so you can use the Hugging Face model also for the embedding generation, because it's just a one-time process to generate the vector DB. Okay. Then I'm using here the Chroma DB for the as a vector store. So just storing the data into Chroma DB. What we have already created the embeddings. So Chroma here, this is a syntax for just generating the Chroma DB here. So Chroma DB from documents, these are the chunks. The documents are the chunks that we already splitted document using a recursive characterized text splitter. And this is the embedding model that already I've defined in this cell. Okay. I hope that's also just you guys also can easily understand what is going on here. So vector DB is created here. The vector DB database is created successfully there in this cell. Okay. So now the first module is completed of the RAG system. The first module is, what is the first module? Just to create the vector DB to use for the retrieval process. So I've already created the vector DB here. Now we are just using the retriever, creating a retriever, because we need to just retrieve it. So I'm just creating the retriever here, where the retrieved document will be 4. So this retriever, this is the vector DB, and this is the as retriever. I'm using LangChain method. So just retrieve the document, the RAG application. So as a retriever, just retrieve 4 matching documents, because I'm using here k equal to 4. So 4 matching documents will be retrieved from this vector database based on the query. Okay. This is a retriever. We can test it. So here I use this query, the experience summary of the document, and just ask that query to the database to just retrieve the matching documents. It will generate a 4 matching documents. So after that, I print all the 4 documents, the top of the documents, matching chunks. Okay. First 300 characters. So result 1, this chunk retrieved. Result 2, this chunk is retrieved. Result 3, this chunk is retrieved. And result 4, the 4 matching chunks that is retrieved after this query on the vector DB based on this query. So these are the 4 chunks is retrieved. Okay, matching chunks. Now, test the agentic process. Begin here. The RAG generation, the RAG implementation with the LangGraph. So we are now in this method, in this approach, I'm using now the LangGraph for building the chat or the agentic RAG application. For using the LangGraph, we need to just first create a state, because state is just the information storage where the information is stored for each state. Because LangGraph is just that we can say that we are creating the graph of a node, the workflow. You can say we are building the workflow between multiple agents. LangGraph helps to just create a workflow, okay, between agents. How these agents are connected to each other. Now we build multiple agents and we connect these agents to each other with the help of a LangGraph. Okay. How? Let's see. So first, I've created the state where the created the class by the name of a graph state. Graph state have a 3 information: the question, the document list of document that is retrieved, and the generation. Okay. So this is just a state. We can see just holding the information on each state. That information is what is the question, what is the generation, what is the retrieved documents. Okay. So just we are holding that information after each node. That's why we created a one state here, the graph state. Okay, then I've created one function. What this does, it defines the retrieve node in our LangGraph workflow. यहाँ पे हम क्या कर रहे हैं? We are creating a one node. ठीक है, जो कि I'm just writing the name of that node is a retrieve. So that the task of this node is to just retrieve the document from the database. ठीक है, this is a one agent. Okay, I'm creating. We can say I'm creating one tool. ठीक है, but it's like in the LangGraph system, you can say we are building one node. Okay, so I created one node which have the capability, which has the responsible for retrieving the document from the database vector DB. उसके लिए मैं अभी बनाया है. We have built this class retrieving documents, and this is the question, where question will come from the state that we have created here. इस state में से हमारे पास question already होगा, then you can directly fetch that question information from the state. So just state just holding all the information on each node. So we can just easily fetch those information from the state at any point of a workflow. Okay. And the question, and this is the response document, and just now we are returning the question and the document, and that document will also store after this node into the graph state in this document list. Okay. Okay. This is the one retrieve node. Another node. Yeah. Okay, that's it. First, I'm just showing you how the LangGraph will work, and again, then we go for the another node. Okay. So now I've created this LLM using a GPT-4o mini model. The temperature is 0 here. So mostly we use the 0 temperature in the RAG because we don't want to use the LLM's its own information to just generating the response. We want the LLM to just rely on the context that we are giving to the LLM. Okay, that are just the retrieval process retrieve those documents. Just generate the response based on the retrieved content, the context that we retrieved. We don't want to LLM just add up its own information. That's why mostly we use the temperature 0. Okay. Otherwise, it will give the response outside of our context. Okay. Now just designed one prompt prompt template, okay, that is used to instruct the LLM. Is crucial for guiding the model to answer only based on the provided context. So we know about the prompt. Prompt is just a guidance to the LLM. So it's guiding this that you use the provided context. Yeah, it's a basic LangGraph system. And after that, we will go for the another agent. After that, I will just add up one more agent. Just first go for the what is the LangGraph, how the LangGraph is working. So I just created a one node, retrieve, and another node, generate, to generate the response. So we have already retrieved the document by using the retrieve node, and I'm creating a one more node that defines the generate node in our LangGraph. हमारे पास एक node आ जाएगा in the LangGraph. Is a node is the task of this node to just generate the response based on the query and the retrieved document. Okay. Is a question. Document. Now context is just merging all the related documents, and then this is the prompt. In the prompts, I've added the context and the question, and the LLM will just generate the response based on the information that we retrieved and the query. Okay, the return these three. These three will go in the this return. It will return the question, the documents, and the generation, and that will be saved after this this complete of this node. After completing this node, when this node complete its task, this information will store into the state. Okay, so at every stage we are just updating the state information. That's why we created a state at the first, because we have every stage of the workflow, we just insert something into the state information and retrieve something from the required information from the state information. Just a state information, just holding the information for the workflow. Okay. Now I'm just creating the graph here. Okay. What we have created so far, what I've built so far, just build two nodes, the retrieve node and the generate node. Okay. हमने दो नोड बना लिया है. Now we are creating the graph. Yeah. For creating the graph, we need the state graph and the end point where we want to end this graph. Okay. So from the LangGraph, we need to import two things: the state graph and the end graph. We initialize the state graph with the graph state, because this is the state. तो हमने इसका नाम रखा हुआ था graph state. Okay. So we are initializing the state graph and then the workflow, and here I'm adding the node. Okay, workflow dot add node. Okay, so this I'm just creating the end-to-end workflow by using the LangGraph. So first step is the state graph. I'm just initializing the state. Okay, so we are starting from the state graph, our workflow, and end up on the end state. So both the starting state and the ending state, I'm just importing from the LangGraph. Okay. The starting state is the state graph. We start from here, and slowly, and then we move towards the adding the nodes into the workflow. Workflow dot add node here, retrieve and generate two nodes. Okay, we have added two nodes here. One is the retrieve. This is the name, and this is the name of that function. We have added two nodes in the workflow. Set entry point. We just enter from the retrieve, and then edge retrieve to generate. Okay, you can just build up the logic how this graph is built up. That I already showed in the whiteboard. So first go from the query state. Okay, so set entry. This is a workflow. I've already added two nodes. Now I'm creating the connections between these nodes. Okay, in this cell, I'm just creating the connections. कैसे कर रहे हैं? Entry point is the retriever. Okay, query goes directly to the retrieve node, and then retrieve node to generate node. Then we need to add the edge between these two nodes, the retrieve and the generate, and generate to end because it's the last state. Okay, so here is my whole LangGraph workflow is created, where there's two nodes, and the entry is the retriever, and the retriever node is then connected to the generated node, and the generate node is connected to the end. I hope it's clear. Is there anything if you want to ask, you can easily ask your question, your doubt. Is it clear?
Thanks for explaining. I have one small query.
Yeah.
Actually, we developed the vector database based on the chunking, right?
Yes, yes.
Yeah. So maybe on our request, it's showing that we are not able to get the first time. So what is the need of retrying every time with the other vector database?
Can you just explain again?
Yeah, sorry. What I'm telling, the initial vector database developed using the chunking, correct? That's done
Yes, yes, yeah.
first time. Yeah. Second time, means you are just giving a request, we are not able to find it, correct?
I'm not able to find the relevant document, right?
Yes. Yeah, relevant chunk, correct. Correct.
Yeah, relevant
So
chunk,
what
yes.
is the need of retrying that one? Because already showing that it's not showing the relevant chunk. What is the need of going once again and find the relevant?
Okay. Yeah. So now you are mixing two things here. Okay. Yeah. So one thing is what I think you are mentioning what I just explained in the whiteboard, right? So there are two use cases I've explained. One is when the fallback logic is to just if the vector DB fails, okay, there's
Oh,
no available chunk, then we go to the fallback, where fallback is to go another source of information, where is the web search comes into the picture.
got it.
Okay.
Got it. Now I'm clear.
Yeah.
Yeah, got it.
Yeah. There's a two mixed two approaches. Okay. So I explained two different approaches there. Two different
Yeah,
use cases.
and I understand now. I understand.
Okay, it's okay. Yeah. Thanks for asking.
Hmm.
Okay. So app now I'm just compiling this workflow and just invoking just simple. I've workflow compile here, just created the app, and now I'm just querying that what is the summary of the document and just retrieving the response. Okay, this is a simple LangGraph. Now I'm creating one more, okay, for the fallback logic, creating one more node for the, we can say the one more agent for the web search. Okay. So how can we use it? I've created one Serper API key because I want to use the Google Serper API wrapper here from the LangChain community utilities. Okay. So I'm just using this. So for this, for to use this Google Server, I need this API keys. So I just wrote it here. Yeah. This is free, so you don't need to just rely on it and need it, because you can also create your own because it's totally free to create the APIs. Okay. So you can easily create your own API key on the server, Google Server, just for the web search. Okay. So I imported Google Server here for the web search. So how it's working? I just created one object of this Google Server API wrapper, initialize it for the in the variable search. Now I'm running this query, latest LangGraph release on the Google Server API wrapper, and printed the result. So what I found, latest release June 18, 20say building stateful. Okay. So what does it mean? Like, so based on this query, it searched over the Google and just give me the response, what it found, what this Google Server found on the basically Google. Okay. Is the response. It may be not correct, it's possibility, but the idea is to just search over the Google, because directly we can see here. I just write a query directly to the search object to using this Google Server API, and now it's showing me some result like June 18, 2026. So may be correct, may not be correct, but something it just showing me, okay, the result in the result section. Okay, now I need to just create a tool for it. So this for the showing, I just print the result, how it works. Now I need to just add it with the RAG retrieval. So I create one more node. Now you have the clear idea. So if I want to use a one more agent, then we need to create a one more node in the workflow. Okay. Now for using the web search, I'm creating a one more node. Node name is web search. So how to create a node? Just create a one function and add in your workflow. So I've created one function, web search. Okay. A state, the input is the state because we need the information. We need to just fetch the information from the state. That's why we are taking the state as an argument, input argument. Now the print, the work of this, the web search, question aega, document aega. Okay. Web result, we found, just we need to just search over the web, the question here. Okay. And just combining the web document, all these different documents, and this, then returning this information to question, web document, and such. So one thing I need to just show, just okay. So I've created one node here, web search, okay? Because I need to just integrate one more fallback logic of the web search. If the vector DB fails, then we need to go for the web search. So that's why I'm adding one more node here for the web search. Because simple, I created one function to receive the information. That's it. Now, because in the previous state, we don't have any information for the web search. That's why I've updated my state, graph state again. Okay. Previously, we have these three information only because I required only the question and the generation of the document. But now I want to just include the web search tool also. Okay, web search node. So I'm just creating, just adding one more keyword here, web search, and the type is the bool. Maybe just is, it will just say, is it present or not? Web search is present or not? Okay, basically whether it is required or not. Okay, yes and no. So I've just updated the graph state. Okay. So now you have got the clear idea. Okay, what is the meaning of the graph state? Just it's storing the information. So previously it doesn't require for the web search, so I didn't use that web search there. But now I'm just creating one more node. That's why I use the web search tool here, web search keyword here. Okay, just creating one more in storage for that web search information. Okay. Now for the basically, I've added one tool, the web search. I have one more tool, the retriever and the generate. Three nodes are already created, right? The web search, generate, and the retriever. One more node I'm creating. This is a simplified create document function. It checks if any document were retrieved. If not, it suggests a web search. So for decision purpose, if this is present or not, if we want to go towards the web search or not, then we need to create the document. Okay. For that, I'm just using one more function here, the create documents. For the create documents, I'm just creating the document and the state create, just retrieving the information, and the length of document equal to 0. Then no relevant document found. Otherwise, go for the web search true. Otherwise, false. If the web search true, then go for the web search. Otherwise, don't need to go for the web search because document is already present. Okay. That's the use of this node. Okay. Okay. Now I'm just adding one more node here, the decide next node. Okay. Because we need to just take a decision making step here. We need to just decide whether to go for the web search and whether to go for the basically retrieval process. That's why I created the decide node next. Okay, decide next node. Now all the nodes are created. Now again, just build up the workflow using the LangGraph. So for that, I'm just using the workflow, the state graph, and the add node, retrieve, then create document, web search, generate. All the nodes are added. Now just need to make the connection between all the nodes. The entry point is the retrieve. Then one edge, retrieve to create document. If the document is present, then go for the don't need to go for the web search. Otherwise, go for the web search. And then add the conditional edge. If the grade document tells okay for the web search, then go for the web search. Otherwise, go for the generate. This is a conditional edge. Okay, either we need to go for the web search or not after the retrieval process. We retrieve the document, then now we are deciding whether to go for the web search or the generate mode. Okay. Then web search to generate node, adding the edge web search to generate, and then ending this workflow at the end state. And compile this workflow. Now invoking with the question who won the latest FIFA World Cup. We obviously know that this information is not present in the uploaded document. Then there is a fallback logic will be generating response. So here we can see the retrieve documents need web search. Okay. First, it go for the retrieving the documents. If it doesn't find any related document, then go for the agent go for the web search, routing to web search, and found this response that identified on the latest FIFA World Cup. This one. Okay. This is a whole complete workflow for the by using the LangGraph methodology. Okay. One more approach that we can use for building up the agentic module. So similarly, in this way, I'm just in this approach, I want to just use the without using LangGraph, we can build the same sort of agentic RAG. How? So this the required packages. Again, I want to just build some the vector DB first. So I'm creating vector DB here. The splitter, chunking, embedding generation. I'm using a FICE here instead of the Chroma DB. You can use any type of sort of a database vector DB. I'm just using the FICE here. And also I'm using, for example, if I want to just save this vector store, then we can save it in the local by using this command, the save local FICE index. It will save in the our local database. So we can pull it anytime by using the load dataset. Okay, load local. So by using this command, this method, we can easily load the FICE indexed the vector DB into our notebook. Okay. Now this is the retriever. Already created the retriever, and the same the Google Simple API key. Okay. Now the another agentic implementation method. So here I'm just above it. I just created the same. Just created the vector DB only. Okay. Now I'm just retrieving. I'm just creating the tools here instead of the going for the with the LangGraph. I'm just using the LangChain method for the tool creation, and where I just imported tools. Okay, here. So this is the imported libraries for the creation of the agent. LangChain agents, I imported the create agent, and from the LangChain tools, I imported tool. By using these two methods, I will create agent. Yeah, here I've created one tool for the retrieve docs. Okay, for searching, retrieving the documents. Another search tool for the web search information. Okay. And these tools that we already created, okay, this is simple creation of the tools. Yeah, simple. You can say that easily we can create the agentic workflow as compared to the LangGraph. All the tools are just listed inside the tools list. Now I'm just initializing the LLM, and the agent is created. Agent is initialized here. Create agent. Model is LLM. Tools list is already given in the above cell. This is the system prompt. Now our agent is already built up. Okay. Now we can invoke this agent to just finding the response of the queries. Where this is the role is the content. To provide summary of the provided document. Okay. Now I'm just getting the summary of the document. I just told agent to just provide the summary. Now you can see the agent is retrieving the documents that I have uploaded and then just generating the response based on this. Yeah. This is one more way of just creating the agentic workflow for the RAG application building. Okay. This is the whole idea of how to build the RAG application and how to just build the agentic RAG applications in the industrial purpose, for the industrial purpose, and for the just the industry use cases. That's all for the agentic RAG. Yeah. So thanks for just connecting with us here in the SSAI Training Institute. We are generally provide such type of generally organized such type of workshops and other interesting webinars for the relevant topics on the artificial intelligence and the cutting edge technologies of the AI, like the generative AI and the agentic AI and all. So, and we have also have a multiple various courses present in the running in the SSAI training institutes on the both ways, the mode and the both in the multiple modes like online and offline. Okay, so if you want to learn this whole RAG application building or with the RAG agentic RAG application building from the scratch, if you don't know about the Python or the GenAI basic fundamentals, so we have one program for the this specific uh, learning from for those who are interested in just building such type of RAG applications with agentic module, and they want to just learn everything from the scratch. They can easily join this upcoming program where we have the duration of the program is the 4 month, where we will cover from the basic of the Python. If you don't know about the Python or programming, so you don't need to just bother about it. You can learn everything in this program from the scratch. If you are new to the AI, you can or you are not you are a beginner, you can easily enroll in this program. So this program is just for the beginners and who wanted to just AI enthusiasts who wanted to learn everything from the scratch to advanced level. So we will move towards from the Python basic fundamentals to the deep learning basic fundamentals. Then we'll cover the Gen AI basic and also the advanced concept like the application building, the chatbot and the speech recognition bot, sentiment analysis, and all the other projects. And the basically the portfolio building and also the financial analyst. This type of a project we also will do in this program. And also at the end we cover the agentic AI. So basically how can you build the agentic modules by using the agentic techniques. Okay, so that's all. This is a complete solution end to end for those who wanted to learn everything from the scratch, for those who wanted to grow in their uh, career, okay, wanted to just leverage this boom in the AI situation, and just you want to who wanted to just learn the everything from the basic building block, not only the tools. Want to learn everything from the scratch to advanced level, from the basic to advanced. How the any such type of a great application, industrial application build up on the by using the Flask, how can you deploy those applications, everything will be covered in this program. Okay, so from the building designing to the deployment, you can deploy to deployment also cover it. How can you deploy any application, any GenAI application, any agentic AI application by using the Flask framework or REST APIs in the production environment. Everything will be covered. Okay, so we are just launching this in the upcoming days. Just go through this. Okay, that's all. Anyone have any question related to the what we have explained so far and related to the course title that we have? This course is just starting from the 18th of July. Okay, if no question, anything to do to thank you.